Hello, today we're going to do a related rates problem on surface area using a cylinder. First step is to read the problem carefully. So I have a closed right cylinder, has a height of 8 centimeters and a radius increasing at a rate of 2 centimeters per minute. How fast is the surface area changing when the radius is 10 centimeters? Okay, then we need to draw our diagram. So I've just got this picture here. I've got my right cylinder, and I know the height of this right cylinder is 8. I know my radius is r. I do not get to use this radius of 10 centimeters until the end of the problem, so we're going to wait on that. The next thing we do is we look at what we have and what we don't have. So if our radius is increasing at a rate, hopefully you see the word rate and think derivative. Centimeters per minute means we're taking the derivative of the radius with respect to time. So I have 2 centimeters per minute. And because it's increasing, we know it's a positive 2 centimeters per minute. All right, what are we looking for? We're looking for the rate. How fast is the surface area changing? So we're looking for the derivative of the surface area with respect to time. And we are also given at the end our radius equals 10 centimeters. So after that, we need to write an equation that relates the various quantities together in this problem. So basically, we need to come up with the surface area formula for a cylinder. If I do that, we know we've got 2 circles. So the surface area is going to be 2 circles added together. So the area of one circle is pi r squared. So we just multiply that by 2. And then we need the lateral face. And if you think about pulling this apart here, you're going to have a rectangle with height of 8. And this length here will be the circumference. And so we know that we've got our length of our rectangle is 2 pi r, and our height of our rectangle is 8. So therefore, our surface area formula that we're going to be dealing with is going to be 2 pi r squared plus 16 pi r. All right, so now we need to find the derivative. So we take the derivative of the surface area with respect to time, which is just d surface area dt. Take the derivative of 2 pi r squared, which is going to be 4 pi r. And then you have to take the derivative of r with respect to t, so you write dr dt. Then you take the derivative of 16 pi r, which ends up being 16 pi. And then the derivative of r with respect to t, which is dr dt. Once we've got our derivative, now we just substitute all of our given information in. So we know dr dt is 2. And we know our radius is 10. And then the 4 pi stays there. 16 pi stays there. And we have dA, the derivative of our surface area, with respect to our time is going to be all these numbers put together, which is 80 pi plus 32 pi. Those are like terms, so we can add them together and end up with 112 pi. And since we're dealing with surface area, we know now that our centimeters are squared per minute. And we have concluded our problem.